to NLP and deep learning workshop given by Massa Baali. I'm Wedad Anbtawi, and here's my teammate Kun Smith are the organizers for this workshop on behalf of FruitPunch AI and Yachts. So now Massa.
Okay, hello everyone. I'm so glad to see you all here. My name is Massa Baali. Today I'm going to present deep learning for NLP. So about me, I'm currently pursuing my master's degree from AUB, and I'm a machine learning researcher. I founded a startup called Clerk, an AI recruiting startup.
Massa, I'm not sure if you are on slide 2 because we are still only slide 1.
Oh, really?
Yep.
I am on slide 2.
I saw that.
Okay. Can you see the slide number 2 now?
I cannot see it. Nope.
Okay, let me reshare my screen.
Yep. And guys, while Massa is sharing her screen again, if you have any question, please post it on the chat, and I and Kun will tell Massa the questions.
Okay, so now can you see? With that, can you see my screen?
Yes.
I can see it, yeah.
Okay, so I founded a startup called Clerk. This is an AI recruiting startup. And I did an internship at Microsoft Research Lab and published a research paper related to the field of NLP and machine learning. I also created over 20 projects in the field of deep learning. So the objective of this session, you should be able by the end of the session to define an input and an output for any machine learning problem, hopefully, and get a good idea about the field of deep learning. So please, I want this to be as interactive as possible, okay? So our outlines, first of all, we will talk about what is NLP, what is AI, machine learning, and deep learning, and we will check multiple examples. So what is NLP? It's natural language processing. So we use it as a human language, such as English or French, but by a computer. What are the examples of NLP? Web search, ads, emails, and customer service, and language translation. So machine learning is now empowering NLP applications. So what is machine learning? What is AI? AI is the effort to automate the tasks, the normal tasks that are performed by human, to automate them by a computer. And machine learning is teaching the computers to learn on their own without being programmed. Deep learning is a specific subfield of machine learning. And as we can see the following figure shows for us the artificial intelligence is the huge circle inside the machine learning, and inside it is the deep learning. So what are the applications we use in machine learning? You can see the face recognition. Once you want to unlock your phone, you just hold your phone and you show it your face, and this is face recognition. What is the stock price prediction? We want to know what is the closing price today for Apple stocks. So we can predict the stock price. Credit card fraud. For example, if you want to buy something on eBay or Amazon, and they want to make sure that this is your credit card. So this is machine learning. Sentiment analysis. We want to check the movie reviews and we want to see if this is positive or negative. So this is also machine learning. Movie recommendation. So you may check in and say that I went, let's say, with someone to a movie, and this one checked in and said that another time he saw this movie. We can say that this is, they recommend this movie for me. So this is movie recommendation based on multiple factors. Maybe I like horror movies, then they will recommend always horror movies for me. So why machine learning? Maybe many of us are not convinced yet. So check this out. This is a Chihuahua dog, and this is a muffin. So we can say that using, let's say, any programming language, if it has 2 eyes and 1 nose, then return a Chihuahua dog. If it has a paper cup, then return a muffin. Okay, does this cover all the cases? I don't think so. Let's see this. Wow. Actually, I can't know. Myself, I'm very convinced now. I wish you are too. What is here? What is the muffin? Where is the muffin? Where is the Chihuahua dog? So in machine learning, we can label them and teach the model how to classify them, how to find the pattern. So I guess 90% now are convinced that we need machine learning. So the first steps are, we ask ourselves a sharp question: how many and how much? If we said how many and how much, this means that our output is a number. For example, in the stock price, the output is the closing price or the opening price. So this is a number. So our output is a number. In the temperature, sometimes we need to know the temperature. So this is a number. How many people will buy this product? This is a number. So this is a regression model. If we want to know if this is a spam or not a spam, if this person is sick or healthy, if this news article is sports or fashion, so this is classification. We have a label. But in the regression, we don't have a label. We have a label, we have a label like this. I wish my drawings. Okay. As we can see here, the regression is continuous. So let's say we want the stock price. So we have a number for each one, and this is a continuous plot. Whereas in the spam or not spam, just we're saying that this is a spam or not spam, but the stock price is always changing and it is continuous. So this is regression and the other one is classification. So the second step is we need to create a data set. So as you can see here, the first step is to create, the second step is to create a data set. How can I collect my data set? We have multiple websites. The first one is Kaggle, UCI, or you can create your own data set. For example, you want to do text summarization. You can reach out to a university and tell them that we need a text and its summary. So this process named data collection. After getting your data, you have to clean your data. So the pre-processing is based on the type of your application. For example, if you are behaving with the text, then you can say that I want to remove the stop words. I want to remove punctuations, stop words. But for example, in image, you say I want to remove the blur. In the speech recognition, I want to remove the noise. So based on each type of application. splitting the data. Each problem, we should split our data into training, validation, and testing. Usually, they split the data into 80% training, 10% validation, and 10% testing. We can split it also into 70, 15, 15. Then the fifth step is choosing the model by choosing the appropriate model. And the sixth step is scoring the model, the accuracy which is like 70%, 80%, or MSE, mean squared error. We talked about the regression. So what is the mean squared error? It's the average of squared difference between the predicted and the actual value. For example, as we said, the stock prices or the temperature or predicting the house price. The last step is evaluating your model. Now you can show your algorithm what your testing data, and you can evaluate your model. So now we knew all the steps in order to create a machine learning model. Now we should prepare the environment. Okay, so this is a tutorial for preparing the environment. If you want to download it by your own, we have something named Anaconda. Anaconda is an environment. You download any library you wish. You download libraries. Keras is my favorite framework. It's a framework for building a neural network. And for sure, we have multiple frameworks. But and the Spider is the IDE. It's a program to use. And the last one is we will use today Google Colab. Google Colab is impressive because all the libraries are downloaded and you just need to write a code. This is what we're going to do now. Okay, so it's time to build our first deep learning model. So let's say that IMDb, they called us and they told us that many people are saying good things about them and many people are saying bad things about them. So they want to, so our input is going to be a movie reviews. The model is a sentiment classification model, and either the output is either positive or negative. So the input is movie reviews, which is sequence of words, and the output is two labels. The first one is positive, the second one is negative, okay? So this is the first step we do, is we define our input and we define our output. So now we are working with text, with natural language processing. So what's the first step to do in the pre-processing? So in the pre-processing, yes.
Before continuing, for the preparation environment, like we will send the slide with the code, so you will download it after. Otherwise, you will use Colab because it's faster than installation for now.
Yes, for sure. We will use Colab because it's really downloading Anaconda about. It will take a lot of time. Okay, so the pre-processing. Let's say the text is this is the best movie ever. So we should tokenize the following. So the best movie ever and the punctuation, the exclamation mark. So by the way, you can remove the punctuation, but you should say that my model needs the punctuation. And the punctuations are, let's say that in the positive, let's say that this is a feature that let me know that could lead me to if you put one exclamation mark, then this is positive. So we should be able to know that this thing is either helping our model to learn more or we don't need it. So the second step, we can't input the text as is. We should transform our words into what? Into numbers, into vectors. So the is the following vector: 0, 0.5, and 1. The best, 0, 1, 0.2. Movie is 0.4, 0.5. So the tokens should be now vectors. And this is how the algorithm or the model reads our input as numbers. Okay.
Okay, Massa,
So
a
now,
question.
yes.
Is it considered stop words or not?
Yes, sure. Yes, it is considered as a stop word. We can either remove if we want to remove both the stop words and the punctuations, we will be ending like best movie ever. So we should decide. We should, let's say we can train our model 3 times. The first time without stop words, the second time without punctuation, the third time without both, the fourth time with both of them, and we can check the accuracy. And then we can say that, the best model is maybe keeping them all, or the best model by removing the stop words and keeping the punctuations. Okay, so we should be able to decide and analyze our problem to check that whether to keep or remove. Okay, so now the architecture. So first of all, we will create our model. The first layer is the sequential. Sequential, it's the easiest way to build model in Keras. It allows you to build a model layer by layer. Each layer has weights, and each layer corresponds to the layer before it. So sequential just helps us to add layers by layers. The second one is the embedding layer. The embedding layer, it's for text data. If your input was text, so you use the embedding layer. For sure, each word should be encoded as an integer, as we see the vectors. And the third layer is the flatten. Here in the embedding layer, we get a 3D tensor. The shape of our data is 3D. So the flatten, transform it into 2D. Then the output is the dense layer. That dense layer returns the output. So, are you ready now to write code?
Massa, before going to code, can you explain more about word embedding, especially for the numeric vector you get, like how the machines are doing word embedding?
Yes, we can add. We can talk more about the word embedding. So here, the word embedding, we have multiple ways for how to behave with this layer. Either the embedding, we can say, let's say, from our words that we do have the vectors, we say that this embedding layer from the words that we do have from the data set, or there's something, let's say, named glove, and there's something named word2vec created by Google, and glove, let's say, it is created by Stanford. So, so you choose how to present the vectors you have, or how to better increase the accuracy. We can talk more about it by the end of the session. So, okay. I don't want them to be lost. So if someone wants me to talk more about the embedding, we can explain more about how to present it more. Okay, so now let's start coding. So we will use Google Colab. So this is Google Colab. So here we will say that file, new notebook.
Massa, your collab is not obvious. It's only like the presentation. So if you can stop sharing.
I will reshare.
Yeah.
Okay. Mhm. Okay. So now the first step, I want to tell you something. This is something very precious from Keras. They have some data set that are built in. So you can say from Keras dot dataset, we can import the IMDb dataset. Uh, the IMDb dataset, they have 50K reviews about both. I guess something is going wrong. Okay, about both. I'm sorry. So as we can see here, that they have 50Ks review, 25 positive and 25 negative. Um, okay, so the first step is importing the data set that we have from Keras. The second step is we want to import the pre-processing from Keras. So again, us import pre-processing. Okay, so first of all, we loaded the libraries for the pre-processing for the data preparation. The second step is we want to set the max features. What are the max features? What do we mean by max features? The max features are when we specify that how many the number of features to consider. So we can say that we need 10K words. And the second one is the maximum length. What is the maximum length? Let's say review number 1 is 35 words and the review number 2 is 5 words. So what we do is the maximum length that we cut off all the reviews to 20 and we pad the short reviews. What do we mean that pad? We add zeros just to input them for our model as, let's say, all of them 20 reviews, 20 words for each review. The second one is now we want to load our data, XTR and YTR, and the testing, XTS and YTS equals. Now we want to load. So we said here import IMDb. So we said IMDb dot load our data and number of words equals max features that we mentioned, the maximum numbers of features. And now the XTR, we said we wanted to what? To pad. So the XTR is the text, the review. The YTR is the label, either positive or negative. So now pre-processing dot what dot sequence dot pad sequences. Same XTR, comma what? The maximum length. We said that the maximum length is what? 20. Now, we need to do the same thing for what? The testing data. So pre-processing dot sequence pad dot pad sequences XTS max len equals, again, max len. So let's see the shape of our data. The shape here, let's see, xtr.shape. Just, I want to show you the shape of our data. XTS dot shape. Okay. So now we're downloading the data. So 25K. We said that the IMDb is all 50K. So here it is splitted into 50-50. We can split it more, let's say. I will show you how we will split it down into the train into validation. So now the second step is building the architecture. So now we did the pre-processing part, and we are ready to write the algorithm. So now from Keras, we should say from Keras dot models import. We will import the sequential from Keras.models. We import the sequential, and from sequential.
Also, can you re-explain
Yes.
what is max len and max fit?
What?
The two variables you have, max fit and max len.
Yes, max feet is the maximum features. How many features, which means how many words. So here we said that the maximum features like 10K. Okay, the maximum length, we said that we need to, for example, I will use the annotator. So, for example, let's say we have a review. I hate this movie. Okay, I hate. So the second review is I liked it. Okay, so this one is 3 words, and the one above, let's say it is 30 words. So this is not normal. We should our input data set should be all with the same length. So for that, we mentioned that we need to make them all 20. How? The one that is 30, we cut it off. It cuts off till 20. And the one that is 5, we padded till 20. So we add some zeros. Okay? Okay. So we said that the sequential. Now we need to embed, we need to, now I have 2 other layers, which are the 3 layers, flatten and dense, and the embedding. Okay, so now we create the model. Let's name it MD and equals sequential. As we said, this is the way how to initialize. So MD equals sequential. MD.add, we start adding the layers. So the first layer we talked about is the embedding layer. 10K, the maximum features, and 8, and the maximum length, input length equals So what does 8 means? The 8 means that we need 8 dimensions for to take a 8 dimension for each 10K words. So this is the input length and equals what? The max length. Okay, so what is the second layer? What do we want now? We have the embedding layer, we have this layer, and now we need what? We need to flatten. As we said that now this is 3D, we need it to be 2D tensor. And the second one is adding the dense layer, which is for the output. Our output, either the positive or the negative. So here we put 1, okay? Always if we have this kind of, and our activation, we put sigmoid activation, okay? Equals sigmoid. And now our model is ready. We need to compile it. md.compile. So please be careful because the second exercise, you're going to tell me what to do. So so the optimizer here, we use RMS prop. And the loss is binary cross entropy. Loss equals binary cross entropy. If we have more than one category, here we only have the positive or negative, so it's binary. If we have more than one category, we say it is categorical binary cross entropy, okay? And the matrix we talked about before is the accuracy. Okay. So now our model is ready. We call the model.summary just to check the layers and to take a full idea about what we wrote. So now md.summary, and now H, let's name it H or history. Now model, we fit the model. Now the training part. So the training part is, first of all, we have the XTR, then the YTR, which means the reviews and the corresponding labels, then number of epochs, let's say now just 10 epochs, just 10. How many iterations we wanted to, and then the batch size. What is the batch size? The batch size, it's how many iteration is utilized in each, how many samples are being utilized in each iteration. So we can mention 32, for example. And now the validation split. This is something built in Keras. Validation split. The validation split, as we mentioned before, we can split our training data set into, let's say, I need 20% from the training data set to validate on. So this is the validation split. And so we say 0.2. And now let's see. Oh, okay. So as we can see here, our model is training. This is the embedding layer. These are the 3D tensor we talked about. Now 2D tensor, 20 times the 8, and the output. Let's see our results. So 10 epochs. Always the loss should decrease and the accuracy should increase. And at the last epoch, the validation accuracy should be lower than the accuracy, because here we are validating our results. We are checking if after training on this training each epoch, we check the accuracy and we validate on new samples. So this is our model is 0.75, so 75%. Okay, so let's plot the validation accuracy and the accuracy. We have a library in Python named matplotlib. So matplotlib dot import matplotlib dot pyplot as PLT. Okay, so we can name this accuracy, and we named this for dot history, the accuracy. So this is a dictionary, though we named it H here. Okay, so then we say val_acc equals h dot history val_acc, and the epochs, let's say, range from 1 till the length of the accuracy, +1. Then now we want to plot. In the plotting, you can see here, BO means like blue and circles. And let's say the label equals training accuracy, and plot EPS comma val_acc label is validation. And now the title, just we create a title. So let's name it like training and validation accuracy plot. Okay, and now it's time to show our plot. So now PLT.
Here are some pictures that match.
PLT.show. Wow. Here we can see the behavior of our training accuracy and the validation accuracy. Okay, for sure we can improve our architecture. We can add more layers. We can change the type of the algorithm. we can increase the batch size, we can increase the number of epochs. There are multiple things to do. So now I need your help with this problem. So back again to our slides. So in the previous problem, we did a positive and negative sentiment analysis. Now we want to do emotion analysis problem. So our input is the same, movie reviews, but our output is either sad, happy, and neutral, and angry. So we have 4 labels. How can we change? Can you please unmute yourself and tell me what did we change in our architecture? If someone just recognized, what did we change? Anyone recognized?
The output used to be binary, either good or
Oh,
bad.
very good. Very good. This is the first
Now
one.
4 options.
Yes.
The activation will change from sigmod to softmax, and also the number of layers, or the number of dimensions in the dense layer itself.
Yes. In the previous one, we put only 1, but now we have 4 categories and the softmax, and the loss is categorical cross entropy. Wow, congratulations, you just did 2 architectures in just a couple of minutes. Okay, so as we can see here, now we create we created one that is related to the sentiment analysis, and the other one related to emotion analysis. We can you should be able to define the input and the output, and then you can change in the architecture whatever you like. You can increase the batch size. You can rechange the validation split just to make sure that you can change also the optimizer for sure. Let's do another one. This is machine translation. We want this one. This session was targeted for beginners. So I don't want to go deep in the architecture of machine translation. We're just going to define the input and the output. So this one, let's say in French, il fait froid. The machine translation model should say that the weather is cold. So, sorry. So, what is this problem? This is a sequence of words, and our output is sequence of words. So our problem is sequence to sequence model. So we need to define an architecture that fits a sequence to sequence model. So for this problem, this is how we solve it. Okay, so again, this should be transformed into numbers and padded, and the other one should be also transformed into numbers. Are we ready for something that we mentioned in the post, that we're gonna tell you how the chatbots work? So ready to build a chatbot? Okay, so let's think for a second. What is the model? It's a question answering. We just type a question and they give us an answer. So how does this happen? Or what is our input and what is our output? Let's try. Can anyone help? By the way, we have multiple ways to present the input and the output based on our problem. So anyone, do you have any insights about our input for the question answering model?
Shouldn't it also be a sequence for sequence?
Yes, very good. Yes, very good. It is a sequence to sequence. But I have another question for you. Is it multiple input?
No, single input.
It could be one input, but in this problem, our input here is a question and text snippet. So the question, let's say, could be the question, let's say we want to do something for articles. So the input is the question and an article, and the answer, the easiest way is to have a one-word answer. So this is a question answering model, and the output is a one-word answer. Let's say we want to ask about what kind of article is this? Then the one answer could be sports. So this is, so we have a sequence of words, and this could be, the output could be either a labels or could be a sequence of answer, a long answer. But the easiest way is just a one-word answer. And the text is to help the algorithm to learn more. So this is one of the models. And now I'm ready to hear your questions. If you want, if you have any questions, and these are the references. And thank you. Thank you for listening.
Sorry, I would like to clarify the part about using TensorFlow versus just the Keras library itself. So a lot of machine learners, in fact, we are very curious about TensorFlow. So then how do we really use the TensorFlow in this case? Does it really help to optimize the?
Okay, so the so the Keras is built over the TensorFlow, but it is easier. So for example, as you can see, the architecture we created is only about 4 or 5 lines. You should, in TensorFlow, the same architecture with the same results is way more longer. So the Keras was created to be like a window for the TensorFlow. So it's easier for you to code with Keras. And now they're improving it. And there are multiple frameworks. There is PyTorch, and there are lots of frameworks. But one of the most famous ones is Keras, and it's well documented. And there are a lot of references for Keras.
Hi, Massa. I have a question about the architecture.
Yeah.
Could we quickly go over the embedding, flatten, and dense, like what exactly they are as layers?
Can you write your question? I can't hear you well.
Yes.
You are talking about the embedding layer, okay. Okay. So, over the architecture. Okay, sure. So the first one, and as we said, that the sequential layer is the easiest way to start building a model in Keras. So it just helps you to initialize multiple layers. So you just, you can, after calling this model, you just add layers. So after the sequential, in the text, you always add the embedding layer. So the embedding layer is to behave with text, is how we behave with text. This one, we can improve it as much as we can by using Word2Vec or GloVe. The flatten layer is just to reshape it. Here we have a 3D tensor. We need to reshape it to get it for our output. So our output is here, the dense layer. It's 1, which is binary, either the positive or the negative, sorry. And the activation is sigmoid. Also, the sigmoid, we use it for the either 0 or 1, either the positive or negative. And the compilation, it's the last step, which is you should know that you have to use the loss as binary cross entropy, and the matrix is accuracy, the ACK. I have a question for you. If our output was a number, so then what are we going to use then? Are we going to use the same matrix? Or we mentioned something in the very early beginning, which is what? The MSE. So here, if my output was a number, then I can use what? The matrix as MSE. Okay? Then here you train the model by fitting the model. Okay? Anytime. Any other questions?
Sorry, I would like to clarify for the embedding layer, right? There's the 10,000, then comma 8, these two parameters. So why do you choose 8 as your dimension?
You can choose any dimension you like, but I just said that for each 10,000 word, I need 8 dimensions. Just learn 8 dimensions. So being able to choose better parameters, you need just to get your hand more dirty and making lots of architectures. Then you can say, oh, I guess this the maximum number of features for, let's say, 1 million review should not be 10K. I guess it should be 30K. And you should be able to train your model. And if after training your model, you check the accuracy and you check your model, then you can say, oh, no, I guess 30K is not good. Let me try something else. Okay, and for sure, you should always just go back to research papers and check what did they do and why did they do that. Okay, did I answer your question? Any more questions?
Hi, Massa. Yes, I have a question. It's a question that it's been asked at the beginning of the presentation about how you get the numbers in the vector. I think that you said that you will answer this at the end of the presentation and you still didn't answer, so I just like a kind reminder.
Okay, thanks.
Yeah, and
so,
one more question about the validation accuracy. So you said that, so should the validation accuracy be always lower than the training accuracy, or the more it approaches the training accuracy, the better?
No, it should be always less, because you have the accuracy. Okay, I'm training the data on this sample. The validation, we're not seeing the sample. So as if you went for an exam and you just, you're doing the exam and you said, oh, let me do my exam, and you studied. So the training is what you studied during at home, and then the validation is your exam. What did you learn from your so for sure, what you read at home, if you did an exam for yourself, is would be higher than the exam you're going to do. So this is as a learning process. So about 80%, it should be lower than the accuracy. And regarding the questions the question we talked about, the embedding layer. So the embedding layer, the words are represented as vectors, as numbers. So as many before mentioned, like the word to vec in that Google created. So word to vec that were created from Google News, for example, is not just to see the word as is. So if you have the word like king and the word queen, so these are similar to each other's. So the word to vec shows you that there is a similarity between both words. So also the word to vec is trained over a library named Genison, which shows you the semantic meaning, not just the word as is. Okay? Any more questions? Do you have any more questions? You're welcome anytime. Okay. With that,
Yeah, I think we can end it here. Massa will send you the code and the slides, and also I will send you the recording. And in case you have any more questions, you can send it to me or to Massa, and also if you have feedbacks. Thank you so much for attending, and thank you, Massa. Hope to see you in other workshops soon. And that's it.
thank you so much. Thank you so much.